Hello everyone, this is our group's presentation depicting our experience in the Payson field trip. And my name is Tyler, and I'm also working with Nathan, Chandler, and Sasmit. To begin, we'll start by giving some background information. The Payson area has a long record of geology to be observed. The youngest layer that was seen on this field trip was 250 million years old, while the oldest was dated to around 1.7 billion years old. There was a lot of different formations and types of rocks that were present in the formations around Payson, spanning this massive amount of time. This vast span of time displays many different geological periods and gives us examples of many different types of deposition, from deep oceans to dramatic uplift and erosion, which helped create the modern Colorado Plateau, which you can see on the pictures on the right, especially the one on the top right, which shows the edge of the Mogollon Rim. These geologic features can also help give us insight into what the environment and life was like during ancient Earth periods.
The Great Unconformity is a space of missing rock layers that is visible in many places around the world, but is especially prominent in the northern Arizona region. It's about 1.2 billion years of missing rock. Bottom layers date to about 1.7 billion years ago. Top layer around 500 million years. And so what happened was erosion weathered essentially the middle layer in between these two layers. And they were uplifted and possibly affected by the snowball earth glaciation. So essentially these two layers shouldn't be right next to each other, but they are. So it's a giant missing chunk in time.
Stop 2. Tapete Sandstone. No fossils were observed in the Tapete Sandstone, and it is considered a beach-type sandstone. The Tapete Sandstone is the oldest Paleozoic sediment formation in the Payson area, and the Tapete Sandstone is the close-up of the Great Unconformity from the Cambrian Age.
The third stop on our field trip was the Naco Formation, also known as the Paleosite. The rocks in this layer and formation were primarily limestone and were light in color and varying shapes and sizes. Much of the limestone had broken off and weathered and eroded away from the rest of the formation and slid down the cliff that's pictured at the bottom and gathered in pieces. There are plentiful marine fossils from the late Mississippian and Pennsylvanian periods of the Carboniferous, which dates to 350 to 300 million years ago, and are preserved in the limestone from a time when much of Arizona was covered in tropical oceans. The top right photo displays a rock containing a crinoid fossil, which you can see in the coiled tubes near the bottom of the rock. A crinoid are animals that actually still exist and are connected to the seafloor by a tube sort of structure. This tube, or stalk, connects them with feeding arms at the top of their body, where they pull in animals and feed. This particular example is an extinct form which dates to, once again, the Carboniferous. And in the bottom right picture, you can see an artist rendition of what possible Carboniferous seas would look like, with ancient types of sharks and fish, as well as the stalks that you can see, which would be crinoids.
Stop 4. Hermit Shale. Hermit Shale is also called the Supai group, and it contains mud cracks. Mudstones were created from instances of sandstones, and some of those fossils can be observed in the Supai group. This time period would be representing the early Permian era. This is the stratigraphic column. It has Precambrian igneous rock at the bottom. It goes up to Cambrian Tapete Sandstone, then the Pennsylvanian era, Naco Formation, and the Permian era, Hermit Formation.
In conclusion, this field trip taught us a lot about sedimentary deposits, as well as how they change over time. Things like weathering and erosion were present everywhere we went. We also saw evidence to back up the theory of ununiformitism and how geological activity in the earth has shaped the rock in the same way it has for billions of years. The igneous rock below the Tapete sandstones also show how rock formations changed so drastically over time. This layer that is directly above the Great Unconformity and was deposited sometime during the Cambrian.
Continuing with our conclusions, we can also conclude that the types of rocks that are present in this region also give us a lot of information about the kinds of environments the Earth, specifically the Arizona southwestern region, had during ancient periods. For example, we can see that there were desolate, barren wastes of the Proterozoic without many signs of life, to shallow oceans of the Paleozoic that have abundant life forms that we see in the Naco Formation, and much more, as well as iron-banded formations showing when oxygen began forming and accumulating in the atmosphere, and much more. It's for this reason that paleontologists, in their study of ancient life, and geologists work so closely, as their work is completely intertwined.